Okay, it looks like we are live for episode 5. Hello, everyone. Hope everyone is having a great weekend. I'm back. As you can see behind me, that there's, my scenery has changed a little bit. I've finally moved into my new apartment, and my partner, who used to do interior design, has kind of decked out the place really nicely. So I hope you guys enjoy the background behind me. It's really nice. The past 2 weeks has just been an absolute whirlwind for me, where I've just had so much stuff on. I was doing live videos with Lillian and writing stuff on LinkedIn, finishing off some projects. Oh, thank you, Adash. Yeah, it's really nice. I'm very grateful to have such a nice place. Really, I think it's just a really awesome thing to have. So for today, we'll just wait for everyone to come online. Make sure that everyone can make it. I'm sorry that I haven't been online weekly on the Sundays as planned before. Just too many things going on at the same time. Hey everyone, great to see some familiar faces in the comments as well. Um, I'm really excited to be back again. Really hope today we can go through a ton of stuff also. I have to slightly apologize in advance because I kind of ran out of a lot of time to actually prepare more for this live. So I hope that the slides and everything that I've prepared can do justice and can really help you with wherever you are in your data journey. Okay. Oh, cool. Good to see you as well. How's it going? Okay, I think I'll give it another 30 seconds or so and we'll start at 2 minutes 30. Um, hope you guys are all ready for another session. Okay, let's have some water. Okay, let's kick things off. So, welcome to episode 5 of Data with Danny, personalized mentorship for aspiring data professionals. Thank you again for spending some of your weekend time with me. I'm very honored to be able to help so many of you and to share some of my experience to hopefully help you guys on your journey and get you to where you want to be in your data career. So for today, we're going to jump right into the iPad. And for episode 5, today we're going to identify some of the different data roles that are available on the market. Unfortunately, I only have time to go through 2 specific ones, but hopefully it covers most of what the people are looking for currently. I'm going to talk through some of the key skills that are required for these 2 roles. And also, I'm going to go through some of the best ways to demonstrate your skill level in some of those skills. So I've kind of broken it up into a beginner, intermediate, and an advanced. To kind of flesh out what level you need to know some of these skills and some of the specific tasks and experiences that I've seen throughout my career, and some of the things that people like to do with some of these skills as well. So without further ado, let's jump straight into it. And at any point in time, please feel free to jump in the comments and ask any questions. I really look at the comments as much as possible to make sure that I'm on track. And otherwise, we'll definitely have a lot of Q&A at the end also. So let's jump straight into it. Okay, so the target roles that we're going to look at today will be the data analyst and the data scientist. And I've highlighted just 4 core skills that you see very commonly in some of the job descriptions for many of these roles that are on the market currently. So I'm not 100% sure if this is specific to the Australian market or whether it applies directly in the market that you're in and in the specific area. But I hope that this covers a lot of the general maybe some of the skills and some of the levels as well for some of these skills also. So hopefully it can kind of give you a better picture of how well you need to know some of these things. So for the data analyst, we're going to go through today the Excel, SQL, data visualization, and domain knowledge. And for the data scientist, we're going to go through machine learning, big data, maths and stats, and software development. So I hope you guys are all ready for this. There's a ton of stuff in here, so hopefully we can stay on track and get through all of it today. Okay, first things first. Data analysts, you will need to know some Excel. And I've kind of broken it up into a beginner, an intermediate, and an advanced level. So let's start off with basic Excel. So when you go into a data analyst role, it could be for a junior data analyst or an internship in data analytics. Some of the most basic things that you'll need to know will be some of the basic functions of Excel. So these could be if, else, or if statements, summing different things, some of those very basic things that you learn as you're just starting off in Excel. Maybe you'll be able to do some very simple charts, things like bar charts, line charts, pie charts, any of those basic things where you see in a lot of very simple data visualizations, you should be able to do it in Excel also. And maybe some exposure to some basic pivot tables also. This is where I've seen a lot of the beginner skills when it comes to Excel. Now, if you see intermediate Excel in some of those job descriptions, some of those skills might include using different types of lookups. So this could be your VLOOKUP, the HLOOKUP. Apparently there's a new lookup called the XLOOKUP. And honestly, I haven't seen it before, but I'm pretty interested to see what it does because it sounds pretty badass. Maybe you also want to start looking into SUMIFs and different sorts of things where you can do aggregations over conditionals, where you're trying to check if something matches a specific thing. Maybe you can do an add-on to the pivot tables, which is slices. I personally use this quite a lot when I was going through Excel a few years back, and they were really useful to kind of add in extra functionality to your pivot tables. You might also want to start looking into some array functions. So the most popular version of the array function will be the index match, where it's very similar to a VLOOKUP. I'm not sure if I can really describe it in a lot of detail now because I haven't used it in quite a while. I haven't been using Excel in quite a while also. So, but in a nutshell, you're trying to match a certain condition from one column or an array to another one. It kind of matches up the different, the positions where they match and brings you back some sort of function. And it kind of runs it and returns you something. I don't know if I described that very well, but array functions are quite useful. I consider them more around like more intermediate to advanced Excel, perhaps. And also another intermediate thing would be formatting. So often we see a lot of, in data analytics, you see many reports that get delivered, or some of the deliverables that you might include directly into your PowerPoint presentations when you need to present some of your insights and your findings. Oftentimes we'll be using Excel to do some of the pretty formatting and make it look all nice and very standardized in a certain template. So that might be very important also when you see kind of intermediate Excel coming in. Awesome. And now if we go into more of the advanced Excel, some of these things might include certain database integrations. So you might have heard of things called cubes. So these are sorts of things where you can there's different roll-ups and cubes, and they kind of aggregated data from the database, and then they made it available to users in the Excel. Sometimes these show up in the form of an add-in or a different plugin that you can install through your Excel. But they kind of enable you to kind of almost do queries directly with the data, but instead you're kind of doing it through pivot tables, for example. It's a very nice way to kind of interact with more data from the organization. But when I think of it in advanced terms, it's more about, yes, you should be able to use them because they're just like any other pivot table. However, the advanced area might be, you might be the one who's actually working with the other teams to figure out what different fields you might want in the cube, what sort of aggregations and roll-ups that you might want, what different data sets perhaps also. So think of this as more like a high-end user who interacts with the other teams who provide that cube service and the database integrations. Okay. Another advanced skill for Excel could be VBA or macros. VBA is a scripting language which can be used to automate a lot of repetitive tasks in Excel. It was actually one of the first languages that I used on the job. I don't think I did a very good job of it, but at the time I was actually running some workshops within the company to show other people how to do it. And I think my approach to some of those things was very pragmatic. So I just kind of, at the time, I wasn't a very good programmer. We have to keep that in mind. And I just kind of had the persistence to kind of go, okay, I want to do this and that in my Excel. And I kind of just fumbled my way through and kept making a lot of mistakes until I finally understood all the different intricacies for the VBA. So I think when we think of advanced skills for VBA macros, think of it more as just automation. I think anything where you can kind of do a bit more auto work is very valuable. And usually in the data analytics space, the more you can automate, the more advanced your skill set is. Okay. Another one that we like to talk about is spreadsheet design also. Back when I was doing some of my internships, you'd see a lot of crazy actuarial spreadsheets where they kind of link to many different data sheets. But they're all very consistent and the format is very similar. So when you copy some of the different sheets across, or maybe you have different things that are going on, all of those references and the formulas that link back to different sheets, they're all the same, or they all match up in a way which makes it really easy to scale out some of your Excel spreadsheets. So thinking about the optimal design and how you can reduce the amount of work and effort required to make new spreadsheets or refer to specific data sets is also quite an advanced spreadsheeting and Excel skill. Hence, I've included it in this one as well. Now, there's also, I've added here complex charts. So sometimes you might be able to integrate Excel with maybe some different data sets. No. You can also combine your Excel with PowerPoint and try and have all those visualizations flowing through seamlessly, where you update some of the data, maybe it flows on directly with the PowerPoint, and it's more of an automation play. Also, when I was writing this and I wrote complex charts, I was thinking more something, maybe being able to do different waterfall charts, for example. They were really popular back in the day, and they were more used for financial start and end periods. But I think one of the advanced Excel skills is to be able to create increasingly complex charts with the Excel toolkit. And we'll talk a bit more about that in data visualization in terms of what sort of visuals are considered maybe more advanced than others. But in this one, I just kind of refer back to Excel. You want to be proficient enough to be able to generate more complex charts. Hope that makes sense. And the last thing I've included for advanced Excel is some statistical analysis. So in Excel, they actually have quite a few tools that actually help you run some optimizations. One of those tools is called the solver, where you can kind of specify a certain constraint that you want different cells to operate within. And the solver can actually find a value for the cell that you want to actually input a value for. I've probably just explained it in a very simple and oversimplified way, but you can kind of look into it a little bit more to find out what the solver can do. And there's a few different variations for what other things you can do within there as well. But also within Excel, you can also build very simple regression models and other types of statistical analysis, which lies more within statistics. So I think having a bit more knowledge about how to use them within Excel is also considered an advanced skill. Okay. So I know that they're definitely not fully exhaustive and they don't cover every single advanced Excel skill out there possible that you could ever do in Excel. But I think here you kind of get a feel for the the different levels that might apply when you're looking for a role that says we need people who are good at Excel. What level of Excel? We need beginner, intermediate, advanced. Okay, great. Any questions so far? Please hit me up in the comments. Otherwise, I'm going to continue on with the next data analyst skill. Okay, so SQL is very, 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 very important for any data role, not just for data analytics, but also for data science, data engineering, machine learning engineering. It's pretty much very, very important. And a lot of the guys on LinkedIn, they're definitely in agreement with these views on that. And I highly recommend that people invest a lot of their time learning some of the SQL, especially because the SQL, you learn how to work with data. Some of the very basic operations that you do with data are expressed in other languages in the same way that it's expressed in SQL. So maybe not expressed, but the logic is very similar to how we deal with the data in SQL. So safe to say SQL is very important. Today, I'm going to try and describe through some of the beginner, intermediate, and advanced for SQL as well. So when we look at the beginner area, you might think of basic queries. So these might be just selecting a few different columns. Maybe you want to rename some of the columns, so you can do like a select column 1 as, I don't know, ABC or something like that. Renaming different columns. Maybe you want to do group bys, so you can select different columns and then run some aggregates over those group by columns also. Perhaps you might want to join some of the tables on specific columns that match. For example, you might have a sales table that has a customer ID, and then also you have a maybe a customer address table, which also has a customer ID and it has the address. So maybe you want to find people who have bought popcorn who also live in a specific state, for example. Some of these different things you can do joins for. What sort of joins might you be interested in? As a beginner, you should definitely be able to express joins such as a left join, where you kind of take the left, well, it's a bit easier to explain if we went a bit more in depth into joins, but there's all these different types of joins and they're all super important. It's very good to know the differences and where you might want to use them as well. I still think that the knowledge of these joins, like the left join and the inner join at least, these should be definitely covered for a beginner, as they're used very, very commonly in SQL. Okay, and here I've also put filters as another simple basic beginner thing that we should also know for anything in SQL. So this usually is just a where filter. There are other flavors where you can kind of do having and qualify, but it depends on your implementation of SQL. But safe to say, just being able to think about filters in the terms of where something is something, or sales is greater than 0, or different things like that is very useful and very much required. Okay, so that's the beginner area. Now if we move on to the intermediate. So as a beginner, generally you'll be working in SQL in a specific window. So maybe an IDE or something that has a connection to the database. When we think of intermediate SQL skills, we'll be running not just individual queries. So instead of just running a select column 1 and column 2, from some table, for example, this is what a beginner might be working on, just trying to query the data directly and it returns you some data. When we think of intermediate SQL, we want to run multiple of these guys. And perhaps we might also be linking them together by using something called common table expressions. These include things like creating temporary tables with statements. But there's a load of different things that you can do within there, where you can kind of express a block of SQL as another input, and then you can refer to it in another query also. So that's very useful. And as an intermediate skill for SQL, generally what we like to say is try and break up your queries into distinct temporary tables. So then you can refer to them as a table, similar to here where you've got like maybe a sales table, for example, but you can generate these tables based off your own queries, and we'll run them as a whole script. So there might be 10 or 12 different queries, and then at the end, you might get some final result that you might want to throw into some data visualization, for example. So intermediate SQL is more around being able to express a solution to a specific problem based off multiple steps and be able to link them together. Okay, I see a question here. I'll just quickly address this one. So when we talk about modeling and capturing data and data frames and different things like that, I will definitely talk about that later. But when we talk about SQL, it's not so specific. So being able to use some of the data for the machine learning and the different modeling things, it's a very specific use case for SQL. What I'm talking about here is more just about in general, if you wanted to ask the data some questions, how would you do it using SQL? And would you be able to string it in a few distinct queries that link together into a script and be able to run that somewhere? So that's definitely an intermediate skill. Another thing that I've written here is basic window functions. So you might have heard these being talked about on LinkedIn, where you kind of get like a row number over partition by different things like that. And you want to, it's sort of a way to break your data into windows and perform aggregations within the windows that you specify. I don't know if I explained that very well, but it's very, very commonly used in SQL. And I highly recommend being able to express whatever you want to do in those window functions. It's very useful. But yeah, definitely window functions. I would highly recommend spending more time on that one if you could. And so the fourth thing here I've put is basic query tuning. So depending on your instance of SQL, whether you're running it in TSQL or MySQL, or there's all these different flavors of SQL. You might want to know, as an intermediate level SQL, you might want to know some basic tuning techniques, such as things where you could choose an index, for example, choosing an optimal index that's well distributed. So when you join something, all the data doesn't live in one area and gets processed. But some of these things you definitely pick up over time as you're trying to run your queries on more challenging data sets. The ability to actually tune and optimize some of your queries actually will be the difference whether you can run your queries. So I think don't stress too much about being able to optimize your queries straight away theoretically. It's much more important to kind of know and learn when you need to optimize. And particularly if you figure out when you need to optimize, when you run into a problem where you need the optimization. So I think don't stress too much if you've never worked with query tuning. Honestly, it's not that difficult. I think you just have to be exposed to it and have to have a need to actually do it to learn it well. But definitely reach out to any DBAs or any of the more advanced SQL guys in your company and just ask them for some tips. Definitely query tuning is really great to learn also, and it really speeds up your work. Okay, and here I've also put handling of types. So as you know, data comes in different formats, such as maybe you have numbers in integers or doubles or floats or different things like that. And maybe for your characters, they'll usually be represented as some sort of string. When I think of handling types for an intermediate level SQL practitioner, it would be about if you're joining certain tables on a certain column, they have to be the same type. Otherwise, you get some type mismatch and you won't be able to run it. So if you were to do that, you should efficiently cast one of the columns to the other one, preferably in the table which is smaller. You can do the casting. So this kind of plays into more of the tuning and the optimization also when you think about logically, if you have more data or less data, you want to kind of run your operations on the smaller set of data because it's going to take less time. But these things you pick up over time spent on working on these sorts of problems in SQL. So just please keep that in mind too. Okay, so moving on to the advanced SQL. Here I've put down just a list of a few things. So here the first one will be complex logic. So maybe, don't know how well I can express it in here, but you might have some crazy case when statements, maybe some regex, regular expressions and different things that you might be using. Maybe you'll have self joins, more complex data transformations, which require a bit more know-how and experience wrangling the data. I think that's pretty much what I'm trying to cover with the complex logic. Let's see. I'm seeing some really great questions, but I'll just run through these ones and then we'll cover some of the questions for the SQL. Also for the next one, the highly optimized. So I talked about it briefly in this in the basic query tuning here, but think of that as taking it to the next level where everything just runs seamlessly as efficiently as possible. When you can do that and you're very confident in your skills to make things run as quickly as possible, then you can consider yourself having an advanced level of SQL. Another point will be the database design. So it doesn't necessarily have to be a specific database, but it could just be a process design also. So in my experience, when we worked on data products, for example, which were expressed mainly in SQL, you would have to think about how you're going to design the different tables that you would create as part of the process to actually get you to the final asset or table that other people will consume. So the way to do this in a more efficient way is you can actually design some of the tables to, you would design which indexes should be used for certain tables and how would you join them to other tables to get the final result. So this is more, it's definitely an optimization and tuning problem, but this design concept is more about thinking through it upstream, like before you even start coding any of this. So you can actually have a very clear picture of the different steps in a very structured plan. So it's more of an abstract planning skill as opposed to a coding optimization skill. Here I've also put data structures. Maybe data structures might not be the best way to put it, but it might be in what I was thinking was more data structures. You could have normalized versus denormalized data. Maybe you would have different sorts of data within a column. So you might have to represent a JSON structure within a string, for example. And then you have to think through different ways of how you'll optimize the query to actually go into the JSON thing to find the thing that you need. So some of these things are a bit more intricate and detailed with some of the data structures, but they're definitely still, I'm sure there's plenty of examples and training tutorials out there where you can play with more complex SQL structures. But these ones are more, they're very problem specific. So say, for example, if you are working with a natural language processing problem, you might have a dictionary or an array within a SQL column, for example, instead of having it blasted out as 500 columns for one column for every word that you have. So some of these are very domain specific, but in general, when you reach a higher level of SQL skill, you should be able to handle these with not much issue. You might be able, you might have to Google it, of course, and refer to some of the documentation, but you should be able to think through the logical steps of how you might do this. And another advanced skill might be productionization of jobs. This one is a little bit blurry because once you get to the stage where you're deploying some of your jobs, whether you are now a data analyst or now are you a data engineer or you a SQL DBA or different things like this, they kind of blur this definition of what a data analyst is. But definitely if you're able to schedule some of your SQL scripts in a production environment, you're pretty advanced. You should give yourself a pat on the back for that for sure. Okay, and the last one might be governance. So governance, we rarely talk about it within the data science and the data analytics space. But what I've seen is say you create your data asset or your different processes that create the data that other people use. One of the really important things is who owns that data? What is the data about? What's the quality of the data? Where is it coming from? How often is it ran? Are there any issues with it? If there's issues, who do you go to? All these sorts of things kind of fall within the governance realm, where it's more understanding the processes of what goes on for some of these data sets. So it's not purely an SQL skill, but it's more of like a meta skill of learning how to manage data in general. So I think that's definitely a more advanced skill. And being able to understand the SQL well enough to actually know where these different points might come into play is where I'm going at with this advanced level of SQL. Okay, so before we move on to the next skill, I'm gonna try and run through some of these questions and comments that have come up also. All right, let's do Ranjan's first. So why do we require SQL? I mean, why can't we simply get all the data from any database through simple query and then do all the data transformations in our model instead of running queries in SQL? Okay, so Ranjan also asked the question about the modeling data also. Okay, so it's a really great question. I think when we think of the modeling component and all the different transformations, yes, definitely you can bring the data from wherever the database is, and then you can do the rest in your Python or your R or other languages. I think, yeah, for this specific thing, when we're talking about data analytics and SQL in general for this stuff, it's more, we're not thinking about machine learning or anything at this point, but definitely you can do some of those things expressed in purely SQL also. Okay, another question. Aravind. Yes, SQL runs nearer to the data, and doing the transformation in the database would be more performant. It'd be executed by the SQL engine. Yes, that's another reason why we prefer to kind of do as many of the transformations within the SQL as possible, because the fact of the matter is not everyone is being able to write Python or R and understand some of the different transformations that are used in those languages. But SQL is much more well-known and very easy to read through and understand what's going on. So yeah, majority of the times, if we have a choice to actually use everything within SQL, we'll kind of lean towards that as a solution, as opposed to jumping straight into the Python and the R. But it kind of depends for different companies as well. So it's not a hard and fast rule or anything. But yeah, just I think being where the data is and running things which is native to the data, like SQL, is very, very useful, I think. Okay. Let's see. Yeah, Vasi has a good comment here about queries in SQL used to extract and retrieve particular data that we need. We want to know which employees. Yep, definitely. Almost all employees. I hope. I don't know. I don't actually know how much people in the Bay Area get paid. And Aravind, probably just another SQL. If you select star from the table and move it into something like pandas, we'd move the whole data through another layer and more memory management and stuff at the Python end. Yes, this is definitely the case. And you also have to manage the different connections from the Python to the SQL server. So maybe you use different, maybe an ODBC or a JDBC connector or different things like that you have to manage that could potentially break on the Python side. Maybe you're loading it from a CSV. Then you have to think about, okay, how am I going to get the data from the SQL server directly into a CSV file? Where do I put it? What do I run to put it? What format do I save it in? All these different questions have to be part of the trade-offs between when you're going to use data in a certain environment versus another. So yeah, these are just different things that kind of come up as you work on more and more projects within the working environment. But yeah, they're really good points. Okay, how are we going for time? 30 minutes. I've only gone through 2 things. Okay, I better speed up. Next is data visualization for data analysts. So here I tried to keep it relatively simple in terms of the skills required, but kind of you should be able to see a very clear difference between the different levels also. So please let me know in the comments if that's not the case, and I'll try and address that uncertainty for you too. Okay, so if we start within the beginner area, oh, whoops, that doesn't look very nice. So simple charts for data visualization. So think of your bar charts, pie charts, line charts, all the different things that are very usually deal with data which is static, maybe single dimension. So you might just be looking at compare sales for the month of June or something for 5 different employees, something very simple. Maybe when we think of the trending metrics, you might have, let me see if I can just draw something really quickly here. It's a little bit small, but maybe you just have time on the x-axis and you have the amount of sales going through over time, and it's sales is increasing, something like that. That might be a simple trending line graph, for example. Maybe, and also here I've put the majority of beginner data visualization level is based off historic data. There's not much focus on what could happen. So in terms of forecasting and different things, which is more in the intermediate, which you can see down here. But yeah, most of the time the data will be static. I think that's quite an important piece of the pie also for data visualization. And also here I've put basic styles. So I'm sure if you guys have been playing with visualizing your data in different environments, such as say a Excel versus Tableau versus R and Python, the styling is very different and unique to each of the different tools. So for a beginner, when you're working in data visualization, the styles are not expected to be very visually appealing. They don't need to be so attractive. You just want to get the data and visualize it. Don't worry too much about making it look really pretty. Okay, so once you have mastered the simple different charts and the way to actually get the data to look the way that you want, we can start thinking about more intermediate skills, which include your dashboardings. So maybe now that you have the ability to do a few different simple charts together, now you can put them together into a dashboard and represent that. Tableau is very popular for dashboarding. R is definitely very popular as well. But yeah, a lot of dashboards in business are still being done in Excel, and there's nothing wrong with that. Excel works really well, and a lot of the business people who are reading those dashboards can actually use Excel also. So that's kind of a big plus too, if they wanted to dig into it a little bit deeper. So don't look down on Excel is what I'm saying. Okay. The next one here for an intermediate skill for data visualization, I've put combined charts. So imagine we have, for example, a line chart, that's our sales over time. I'm sorry that the charts are so small, actually. So say this is sales over time, and maybe just for just because we might be also plotting some sort of bar chart on the same axes, or maybe it's a different axis. I don't know if you guys have seen this on a different axis, where this is units or something, and that's the bar chart maybe represents the number of units that have been sold in that month also. So maybe you want to combine a few different simple charts into a combined chart, which is a little bit more complex, but demonstrates much more data and depth in the single visualization. So that's another intermediate skill, I think. Okay, another one might be simple forecasting. So oftentimes you'll be asked to, okay, what do you think the sales will be next month based off seeing all of these sales going up in this direction, for example. So maybe you could kind of give them some sort of extrapolation in the future time of where the sales could go. And that actually is very useful when we think of making business decisions, where oftentimes the decision to run a project or not run a project is very dependent on what they think the sales will be in the next month, next year, next 10 years or whatever. So forecasting is very, very important, and being able to visualize that in a very appealing way to actually make it very understandable is very useful and definitely should be included in an intermediate data visualization skill set. Okay. Here I've also put down multi-dimensional. So you might have seen, so charts like this one that I just drew with those combined charts, it could be known as multi-dimensional also. Another one could be, you can simply have column or bar charts or something where you use the color to try and flick through the different people who are there or the different I don't know, company values or different things like that. But another layer of data in there to kind of give you more complexity. So being able to manage more levels of data in one chart is very useful. And I think that's definitely, yeah, we should know that as a practitioner for any data visualization. And the last one here I've put is improved style. So once you reach a middle level of data visualization, your charts are expected to look at least presentable and quite nice and very simple to understand. I think having that skill to be able to make the chart look exactly how you want it in terms of the styling is very useful and should be known also. Okay, I'm just going to undo some of these ones so we can see what's going on. For the advanced skill set, okay, I think I'm talking pretty quickly. So for the advanced skill set, here I've put animated charts. So you might have seen that racing car plot or different things that have animations and kind of move your different things up and down. They're very cool, actually. And I've seen some code from someone in the Data with Danny in the Slack channel try and build that stuff. So I think it's really cool. But that's not the only animated chart that you can do. There's tons of stuff which is really cool. There's actually a whole JavaScript library called d3.js, which is specifically for doing browser-based interactive and animated data visualizations, which is super cool. But yeah, there's a ton of stuff. A lot of it, unfortunately, it will be definitely within a Tableau or an R and Python. I think with the flexibility of those tools, that's where you can kind of do what you want with it. So I think for that reason alone, it might be why it's placed within the advanced section for data visualization. But also when you're doing animated charts, you have to kind of think through exactly what you want to animate and also what lens you want to animate over time. So for example, a lot of the common animated charts are animated over time. So you kind of see like the stock prices for the past 50 years of top 100 companies or different things like that, where it's very easy to understand when you have the time factor. Other ones could be based off number of actions or steps or different things where customers are buying, or yeah, it's very broad and you can animate pretty much anything as long as you can think through what you want to animate. And that's the difficult part of why it's more of an advanced skill. Okay, the next one here that I've put is interactive. So you might have seen those data visualizations or dashboards where you kind of click on one of those buttons and then it pops up another data visualization or another chart, and it gives you a little bit more detail and maybe a little bit of a story of what this chart is about. And all of these things are kind of, we lump them into what is called interactive data visualization. A lot of the Tableau is very good at this, R is very good at this, and Python is definitely very good at this as well. I think in my career, I've used much more R for doing my interactive data visualization, but all the functionality and some of the different packages are also available in Python too. I haven't used Tableau as much, so I can't really comment on how easy it is to build some of those interactive data visualizations, but I'm sure it's definitely can be done, and there's a lot of support on Tableau also. So you might want to look into that as an option if you haven't started mastering some of the R and the Python. Okay, here I've put tailored to audience. So this is more like a meta skill when we think of data visualization. So sure, if say we get the data and we try and draw some charts to try and get some insights and try and figure out what's going on, it all boils down to how well can you pitch your message to your audience. And that is a more advanced thing to do, and it definitely takes more experience. But I think, yeah, when you understand who you're presenting your charts to, or who might be using your charts to make some decisions, you'll frame up the data in a different way than if you were just framing it up for your own analysis or exploratory feature analysis, for example, for machine learning. So being able to understand who your audience is and being able to tell a really coherent story through your data visualization is super important. And that's why it's also very difficult to do well. And that's why it's in the advanced section for skills here. Here I've put great design. So by design, I mean visual design. It looks amazing. So here I've seen a few different people who were really, really good with data visualization, but they were not super technical. So they actually were very good visual designers, and they were very good with things like, say, a Photoshop or a Canva or different things where they can kind of craft infographics. Like, I'm sure you guys have seen infographics, which are amazing. And they just tell you the story that you want to know, and all the data points are fully on point, and it's just like really, really cool and engaging. So if you can build those sorts of visualizations as a data analyst, you're super. You'll be amazing. But it's definitely not a skill that everyone has. Like, for me personally, I have no idea how to use Photoshop, no idea how to use Canva or anything like that. So it's very difficult for me to actually like build out some of those data visualizations. So for me, I would try and code it out. It would be easier for me to code it out than to learn some of those tools to actually make it look really pretty. So I'm kind of at a disadvantage here. But the thing to know is that if you can draw out what you want and kind of work closely together with a design type person, then that's where you can get a really good synergy of skills, and then you can actually deliver something which is really awesome, and you don't have to break your back over learning a new program to do it. So yeah, highly recommend if you need to work on some of the design components, talk to a visual designer or a UX designer or someone who has more of that creative background than you do, and just ask them for advice. Like, I want to do this with my dashboard or my visual. I'm trying to tell them this story. You never know what they might come up with, and you'll definitely learn something from them every time. Okay. So another one here is I put self-explanatory, and it kind of links in with a little bit of the design, but it's more of like a UX design thing. So for some of the charts, when you get to a really advanced level, you just want to, one of the tests is to show the chart to the person who is least likely to understand it, and that's the level of charting that you need to do. So a lot of I'm sure you guys have seen many data visualizations which are just absolutely crazy. And it takes you almost need a PhD to understand what's going on with a specific data visualization. So it's more about being able to trim down the message and keep it super explainable. So then it can actually, people who need to make decisions can actually understand what you're trying to tell them in a very simple manner. And almost the chart should explain itself. Like, there should be enough the styling should be nice enough. There should be nice enough cues within the chart to actually let the party who needs to make a decision know what to do with it just by looking at the chart. So that's like a hallmark of a really great data visualization expert. Okay. Cool. So that's 3 out of 4 skills for data analyst. I'm up to the last one. I still have 4 more skills for data science. So I'm really sorry if I run over today, but we'll see how we go for time. Okay. So for data analysts, I've also put domain knowledge. So this is super important, not just for data analytics, but specifically for data science also. We really need to understand the business and know what problems we're trying to solve. And for data analytics, it's more around if I'm going to try and do some analysis or try and bring some insights, what's the problem that I'm trying to solve? Like, how do I know that I'm doing the right thing? Will my data actually answer the problem? All of these things are super, super important, and arguably they're more valuable than some of the technical skills also. So just keep that in mind when you're going through some of the different exercises where you have to try and, like, a lot of the exercises and tutorials that we see out there, they're all technical based, which is Of course, they're much easier to learn online than trying to get the domain knowledge. But keep in mind that the domain knowledge is where you can really add a lot of value. And just being able to do a very simple data visualization, but be able to pitch it to the right person with the right message to drive a huge action could be much more valuable than trying to boil the ocean, for example, and trying to do something really, really complex that no one will understand. So yeah, so let's go into domain knowledge. So if we go to beginner level of domain knowledge, we want to see at least some familiarity with the industry. So say it's in retail, you might want to know, okay, in Australia, who are the biggest retail players? There might be a few different supermarkets. Maybe there's some different things, different stores. We call them like Myer and David Jones, or different retailers, Kmart, or different things like that, and kind of the niche and the different audiences that they serve, or customer groups that they serve. So a little bit of knowledge around what's going on. Definitely you should have that if you're applying for some of these roles in a specific industry. You also want to know some of the basic trends. So for example, let's say you're working in the motor industry. You should know about self-driving cars. Maybe you want to know about renewable energy, different things like that. Some of the trends, which you can probably just read on the news or just think it through and think of where the industry is going to go in the next 5, 10, 15, 20 years, and try to, I don't know, at least communicate that you understand where that sector is going, because I think that's really important to demonstrate your knowledge of the role that you want to apply for. Okay. And the last one here is still data related. You should be able to at least identify in very broad terms some of the data sets that you might be using within that industry. So for example, if you're going to work in insurance, you should know that maybe there's like some policy data or the claims data. Maybe there's a customer database of where people live, their different policy numbers and different things like that. And maybe for retail, maybe you'll get their transactions, their preferences, what emails have we sent to them, have they clicked on any emails, different things like that. They don't need to be data sets, but you should be able to think through what are the available data points to you in that situation if you're working as a data analyst in that area. So I think just thinking through some of those things before you apply for a role, or if you're going for an interview, just having those things front of mind can really get you in the right headspace when you're talking to one of the hiring managers, because then it demonstrates that you're keen to work in that area, which is super important if you're interviewing, and also that you have some interest in the area, which is also very important. Okay, so those are for beginners. Now, when we think of intermediate levels, this one is a fun one, and I thought of it as I was building up these slides for today. The intermediate data analyst will start thinking about different techniques which aren't traditionally used in that area. You hear this a lot for data science and researchers a lot, where researchers kind of just apply all these novel ideas to different problems and see if it fits. So when we think of domain knowledge and having an intermediate level of knowledge, you should be able to have a good intuition of, oh, I have this idea. It comes from, I don't know, say physics or chemistry or some other abstract field that almost doesn't have anything related to the field that you're working in. But when you think of the data and the different things that it could work with and the different applications, maybe it will work. And then you can kind of try and run an experiment and try different things. So we can think of that. It's more like an intermediate/advanced skill, but I think it's definitely it's more of a creative pursuit. So it's definitely for the creative thinkers and the different people who come in and they want to demonstrate some of their knowledge, but they also want to demonstrate their knowledge in how can we use new things to improve what we're doing in this area. So I think that's really cool. Here I've put understand data processes. So we talked a little bit about this in the SQL component, where someone is supposed to come in and be able to say, oh, here's where all the data is coming from. Here's all the different pipelines and processes that run to generate the data from a sensor on a Tesla all the way through to the database on the cloud for a Tesla factory or something like that, where you just have a lot of different processes, and being able to understand the process well enough to actually know what data do we have, where is it coming from, when can I use it? How can I use it? Who else is using it? Who was this data designed for? Having all these sorts of skills. I don't know if they're an intermediate skill, but it's a very useful skill to have. And the more important thing is just having that curiosity to find out more about the data. I think that's more important than actually demonstrating that you understand the data processes, especially when you go into a new role that you're interviewing for, because you won't know what the processes are for that company. So you can't really like fake your way through it. One of the things that you can just demonstrate is your curiosity to understand how everything works. I think that's where this plays in. Okay. And the last one for the intermediate skill will be suggesting new data sets for the business. So for example, say you're working in a digital environment and maybe you want to try and optimize some of the different pages that the company has to try and make more clicks or have more sales or different things like that. So you can potentially try and identify different data gaps where maybe their tagging is not right on some of the pages. So someone who clicks on that buy now button, you actually don't, you see their transaction go through, but you don't know that they clicked that buy now button on this page. Different things like that, where there are gaps, is super important. I think being very curious and creative is where you can kind of suggest new data sets or new data points that maybe people haven't thought about. And I think for me, when I had some of the interviews where before I went into the interview, I tried to come up with, if I'm working for a digital business or something, what are some of the things that I might do with their data? Just write down a few things, brainstorm a few things, or what different data sources might they not have? Which are some of the more creative things that I can think of that they might not have, so I can impress them or give them a different perspective or different things like that. I think having that mindset is very important when you're going for some of these roles. Okay, for advanced, these ones are, so I put down thought leader. So if you're a thought leader in your industry, of course that helps. How you define yourself as a thought leader, I'm not really sure. You kind of need to be, I don't know, maybe posting on LinkedIn a lot. Maybe you write a book, write some articles. I don't know, something like that where you can demonstrate that you're really well known in your industry. But I'm not sure how well this applies for this domain knowledge, but it's more just like if you were a thought leader, then you have advanced domain knowledge in that area, regardless of what your technical skills are. Okay, another one here I've put is design new processes. So this one will be super interesting, especially for the analytics folks who want to move more into like a consulting / management role. So if you can show that you have really great domain knowledge, so much domain knowledge that you can help redesign what they're currently doing and make it better, make it more optimized, have better data sets or different things like that. If you can design those different processes, you're doing really well. Another one would be connecting with many stakeholders. So communication is a very, very important part of data analytics and data science and engineering. Being able to talk with many different people from around the different businesses that you work in, that's super, super important because most of the time when you're working in larger organizations, the data lives everywhere. And people from everywhere will know about the data that you don't know. So you have to go out there and meet them and try and find out from them what they know about their data and whether you can use it in your project. So different things like that is super important, and it's definitely a soft skill. But when you know that someone demonstrates some of those skills, it's super, super impressive because you know that you can rely on them to kind of interact with all these different people to find out more about the data. And that's super important. And the last one I put here is they've got experience leading projects. So kind of it all ties in with what I've been talking about just then, but with a bit more like solid work experience. I've led this SQL project or something that delivered X million of dollars for the business over 3 years or something like that, where it's very tangible. Okay. So I've actually hit 1 hour already. How is everyone going? I'm not too sure if I can actually go for 2 hours if I keep talking about the data science, because I have much more about data science than I do about data analytics, unfortunately. So let me know in the comments. I need to have like a big glass of water because my mouth is getting really dry. But I'm going to try and answer a few more questions in the comments, and then we'll see if you guys really want me to continue talking about the data science. I can, but I'm just not sure how much I can cover it before you guys kind of get bored after, I don't know, 90 minutes of talking about data or whatever. So yeah, just let me know in the comments and we'll just see how we go. I'm just going to grab some water from just over here. All right. So per tap is good to go for another hour. I will. I think I can do it. Yeah, I think everyone wants to do the data science actually. So let's just continue, and we're gonna have like a mega long live. I'm very grateful that you guys are still here and listening to me. So yeah, this is for you. We'll do it. Okay, let's get back into it. All right, so we've talked about data analytics. Now let's talk about data science. And the first data science skill that everyone really loves talking about is machine learning. Okay, there's a lot of stuff on here. I personally really love machine learning, so it was hard for me to kind of break down the different things. So let's just kind of focus in on one section at a time. So we'll just go for beginner. Okay, maybe this zooming in was not such a great idea. Okay, so when we think of beginner machine learning skills, we definitely want to have knowledge of the machine learning pipeline. So this includes things like getting your data, having the feature engineering, doing the feature selection, model metrics, and being able to understand and implement, or maybe not implement, but be able to use some of the basic algorithms. So some of these algorithms could be your linear regression, your random forest, your decision trees, XGBoost, boosted trees. Maybe you start diving into some of the deep learning. But the hallmark of a more of a beginner machine learning practitioner is just being able to just import and use some of those packages without having to think through too many things and be able to get to the result. So for this one specifically, I actually think Kaggle is a really great place to learn some of these skills. I know a lot of people bash Kaggle because they say things like, oh, but your data set, you just get given your data set. In real life, you don't get given your data set, which is, it's not entirely wrong, but definitely Kaggle has its place for learning some of the machine learning steps, especially some of those pipelines. And I'd argue that a lot of the guys that are participating and competing in Kaggle, they're really at like the cutting edge of all the different technology and the different methods that you might be able to use for, say, your feature engineering or the feature selection or the model selection or different things. So definitely, if you want to become an expert in machine learning, I wouldn't say that you need to go to Kaggle, but it's somewhere that you should at least investigate and try and find out more about what other people are doing in that space. So I'm going to try and answer some Q&A whilst we go. Okay, where can I find retail domain projects for practice purpose? I've done a few on Kaggle, but they haven't really given me much domain knowledge, especially in retail. Okay, so that's a pretty good one. I think in Kaggle, I've actually seen one of them, which was really famous maybe 5 or 6 years ago, called the Rossmann store sales. So you try and predict the sales from some hardware store or something for a future time period based off their past data, and you get measured on like some of the metrics. That's more like a pure forecasting sort of thing. Other things I've seen is probably some click prediction on some digital website or something, which is really common. A lot of those things, we kind of think of it as signals processing or event prediction or different things like that, where you don't need so much of the domain knowledge, but more of you need the knowledge to know how to frame up any sort of prediction task into one of those classification tasks, for example. And that itself is a skill that can be applied across different sectors, and you don't necessarily need to have retail knowledge to do it. You just kind of have to need more machine learning experience to be able to do those sorts of things in any sector. Okay, so let's get back to here. So we were talking about the beginner things for machine learning. So that's that. If anyone disagrees or if they have any different ideas or whatever, please feel free to put it in the comments and we can talk about it straight away. For intermediate, here I've put hyperparameter tuning as one of the core things. So for people who haven't done a lot of the machine learning, hyperparameter tuning, you can think of hyperparameters as all these different knobs on this crazy machine that you can kind of turn up and down and fiddle around with them until it gives you a different model score or an output. The hyperparameter tuning is where there are a few different methods where you can kind of figure out how to turn those knobs to give you the best result. And you get to define what the result is. So you might have different metrics. You might have heard of things like RMSE, root mean squared error, or you might have, there's a lot of them, say log loss, or different metrics, maybe accuracy, AUC, or different things like that, where you can choose what metric you want to optimize for, and the hyperparameter tuning just kind of changes all these knobs in a very systematic or random way. Or you can manually figure out how you want to do your hyperparameter tuning to get the best model. So yeah, definitely, I think intermediate level for hyperparameter tuning, you should be able to know what you're doing, understand the different types of hyperparameter tuning. So there's like grid search, random search. Maybe you can do different things like cross-validation with some of those regimes, k-fold cross-validation. Maybe you want to do, if you're more advanced, you can do Bayesian hyperparameter tuning, where it kind of does it sequentially and identifies a space where it searches for a different set of hyperparameters to tune on. But yeah, the area is quite deep, but I think for intermediate, you should be able to at least know like the grid search and the random search and be able to explain the differences between them. The rest of it might be more advanced, and you can definitely spend some time learning it. These days, I think Bayesian hyperparameter tuning is very popular. So yeah, definitely give that a go and see how it goes. Okay, so the next one here is applied machine learning for business. So generally, machine learning in and of itself doesn't really have any value. It only has value when you use it and apply those outputs to something. And in most of the time, it's being able to understand the business problem and have enough domain knowledge to actually link, oh, I can do this machine learning task with something which is related to the business and actually solve a problem and help them make a decision or help them target the right customers or different things like that. Okay, the next one here is algorithm internals. So when I think of intermediate machine learning skills for data scientists, I think of you should be able to, at least in maybe not in too much detail, but you should be able to express in pseudocode what the, say, a logistic regression, what's going on under the hood. How is the loss function calculated? How does it get updated? What sort of gradient descent things that's going on underneath? Maybe for a random forest, you might be able to explain all the different bagging methods and different things like that are under the hood, that if you were to just use those algorithms, you don't necessarily need to know. But as an intermediate level machine learning practitioner, you should be able to at least talk through some of those things in a lot of depth and like at least know enough to kind of say, okay, here's the general concept. If you told me to write down the math straight away, maybe you don't need to do it. Most of the time you could just go to Google and just take a look at it on there. But I think, yeah, definitely if you could try and implement some of those algorithms from scratch, it would be very good. But it's not a major thing. I wouldn't have to pin all of your knowledge to that as well. Okay, another thing will be model interpretability. So these things might be, okay, your model comes out and the score is really good, but why? So there are different tools. You can use your feature importance. Maybe you can use something like LIME, which is, I forgot the actual acronym, what it stands for. I think it's like locally interpretable machine learning explanations, model explanations. Yeah, I think that's it. But there are different technologies and packages and things that you can use to explain why your model is making a certain prediction. Having that knowledge is definitely within the intermediate practitioner space, and you should definitely learn it. I think it's super important. Um, the next one here I've put is automating pipelines. So here, by pipelines, I mean those simple machine learning pipelines. So maybe here's where you start thinking about AutoML, for example. So say you have your data set, you want to process specific parts of your data set and the features in a specific way. Can you code up certain functions or recipes that you can just apply to the data to start automating more of that, the dirty data cleaning work? Okay, and the last thing that I have here is maybe they'll start reading and taking an interest in some of the research papers in machine learning. So at the moment, there's a lot of research in the deep learning space, but there's definitely a ton of research in other things also, such as recommendation systems or being able to explain the models better. So like the Lime and the Shapley and the different things like that. I think just, yeah, when you talk with someone and like one of the best ways to demonstrate your passion for machine learning is to start reading some of the research papers and try to find out what some of those guns at the cutting edge are doing and trying to understand what they're doing as well. I think that's super cool. And usually when, let's say, a hiring manager notices that one of the people likes reading some of the papers, it's pretty impressive. Even if they can't implement it or they're not working in that field, just having that interest and demonstrating that interest by knowing what the research is about is pretty cool. Like, I think it's pretty cool. So yeah, definitely, if you're super interested in machine learning, you should be reading some papers. I think you'll really like it. Okay. Now for the advanced machine learning. Like, I'm sure there's tons of stuff that I've missed in the intermediate and the beginner level of machine learning, but it kind of, at least this gives you a flavor for some of the different levels that are there. So when I think of the advanced machine learning, we're thinking of people who actually do research. They're trying to build new algorithms, or they're working on someone's, like some actual algorithm, say like scikit-learn or something, and they're making contributions and they're actually coding some of the code base. So you know that they're pretty advanced. That's pretty hardcore. That's really awesome. The next one could be, here I've put understands trade-offs. So this one's more of an experience play. So when we talk of trade-offs in machine learning, it's in the way where you think of, okay, we can use a very complex model and it gives us, say, a 95% mean average precision, or 95% accuracy or something. But if we were just to use a very simple model, say a linear regression or something, we would actually get 93% or 94%, and it's very easy to train, very easy to deploy. It's just very simple to manage, and a lot of the processes are very cheap and easy to do. So I think, yeah, when we think of trade-offs, they're in terms of cost trade-offs, management of code-based trade-off, tech debt trade-offs. So it's more around the operational aspect, as well as some of the technical trade-offs also. So some of the different algorithms might work with different types of data sets. But yeah, that's more of like you get into it more and more as you think through some of the different scenarios that you might be using machine learning. But this one comes more with experience, I think. Okay, so the next one here is production machine learning. So anything in production is where you set it and forget it, or not really forget it, but you set it in some process where it just automatically continues running your model, extracts the features from wherever it needs to get it from, scores them, and publishes those scores somewhere for some downstream system to pick up or use in a campaign or different things like that. So it's kind of like machine learning automation, but with all the different data bits connected as well. So definitely it's a more advanced skill, but we're seeing more and more these days. This production machine learning is starting to move towards the intermediate machine learning practitioner space skill set, because a lot of the production work is becoming more and more apparent. That's where a lot of people need to focus on. So what we're seeing is production machine learning experience is super, super important. But at the moment, not too many people have it. But over time, more and more people will have it, because we need more of the machine learning solutions in production as opposed to being ad hoc and experimental. So yeah, just something else to keep in mind as well. Another advanced machine learning skill will be experimentation with machine learning. So these could be in terms of testing different algorithms on a specific problem, in terms of setting up how you might do the actual machine learning problem in terms of the hyperparameter tuning and the model selection. But in terms of this one, when we think of machine learning experimentation, it's more around how will you use your outputs from your model, and how can you build experiments to actually calculate the uplift of something, or how do you compare two models in production in a very specific way. So it's more around a statistical analysis of the machine learning outputs, as opposed to having deep machine learning experience. So I think it's still super important to have the machine learning, but think of this as like a next meta level of machine learning experience and skill set, where you're kind of abstractly looking at the machine learning models and thinking how you can run experiments with them. So yeah, it's pretty cool and kind of abstract, but over time, I think more and more people will be moving into the space, so don't worry too much. And the last one here is embedding machine learning into existing processes. So this one ties in very much with the domain knowledge that we talked about with the data analyst. But in this case, instead of understanding all the different data inputs and all the different things like that, a great machine learning practitioner will be able to pragmatically navigate through all the things that are happening within the area where they want to use their machine learning model. And then they'll be able to talk with the people and communicate with the people that they need to convince to actually get their solution to be ran in a test, for example. All these different things are very important, and they're more soft skills, but you see them more in more experienced machine learning practitioners, because it's one of those things where you just need to do it to actually get your project out the door and to actually have a successful project. So definitely super, super important. Yeah, okay. So machine learning done. I still have 3 more bits. So here for data science, I've also put big data. So I think a lot of people think of big data and they kind of relate it to the FANG companies, your Facebook, Amazon, Netflix, and Google. But my opinion is, as we get more and more data, definitely more of the data will be big data. But then if you think of the data size, that's all good in terms of some of the more traditional data sets like MySQL or SQL Server and Teradata or different things like that could potentially just scale out, and then you have larger data sets in there. So here I've put down, for a beginner in big data, you should be able to run SQL pretty comfortably on large data sets in some of the traditional SQL areas. In order to actually run some of the SQL across large data sets, you should be able to optimize slightly, because some of the different decisions that you make will actually have a large impact on how long some of the things take to run. And this is where the term, well, I think anyway, where big data comes in, where big data is where the data is so big, if you need to run anything over it, you have to do it in parallel, and you have to do it in a very optimized fashion. So yeah, large data sets. The next one would be starting to work in Cloud SQL. So Cloud SQL, I think of this as your Google BigQuery, your Redshift, Amazon Redshift, and Azure. I think they have, I forgot the name of it, but there's like Azure MySQL or SQL Server or something that's deployed on the cloud. So these sorts of things, they kind of They work with probably a load balancer and probably some scaling in the background. So if you run a query or something, maybe the optimizer will not just optimize your query on the infrastructure that's currently there, but in the background, it will automate some of the processes to spin up larger things in the background to actually run your queries across a larger instance, for example. But for a beginner, all you need to know is, can you run SQL queries in that environment? If you can, then yeah, this is good. You have some big data experience also. And the last one will be the Spark and Hive SQL. So Spark and Hive are really popular big data frameworks. I think they were both created, they're both by Apache. I think they were both created within Facebook or something. I mean, someone can correct me if I'm wrong. But when we think of Spark SQL and Hive SQL, they're very commonly used frameworks in companies that have those big data frameworks in place. This could be on the cloud, or it could also be on-premise in Hadoop clusters. So I think, if you're a data scientist and you've run any of these SQL queries or anything like that, then you can consider yourself maybe a beginner to intermediate level of knowledge of what's going on there. For people who haven't had the chance to do that, there's not much to it. It's just like normal SQL, but it's just in a different environment and it's a different flavor. So nearly all of the different the same things apply for regular SQL. So you still need your select statements, your from statements, where statements, some of the window functions, and the common table expressions and things. Maybe not common table expressions, but some of the other things are in there for the Spark and the Hive SQL. But you can still write SQL and you can run it on the cluster and it'll just run it for you also. Okay, so when we think of big data for beginner, it's just, can you use big data? Now, when we think of big data for an intermediate level of big data knowledge, we think of, okay, if you're using Spark or Hive or any of the other Apache big data tools, can you integrate it with your current R or Python process? Let's say you get your data. So this kind of talks about the questions that we had earlier about why not just run all your data in SQL and then bring it into R and Python and then do everything else with it? So this question specifically, when we think of this one, this Spark Hive with R or Python, that answers it's more focused on that part. So being able to effectively use the data in the different environments and then switch over to your tool of choice to do some of the machine learning is definitely a skill that is required as a data scientist within this space. But yeah, that's why I put it in here for that. Another one would be parameterized scripts. So think of it as, maybe you have a process and you want to run it the first day of every month or something. How can you put in some variables that kind of automatically pick those up and just run the thing for you? These things, when you parameterize it within this environment with some of the big data tools, might be a little bit challenging and requires a bit more software development skills. But I think, definitely a intermediate skill here. Whoops, that was a rubber. So here I've also put partitioning strategy. So when we think of big data, usually we'll split the big data sets across multiple files, and these files can be stored within partitions. When we try and look for the data, so let's say we're doing a select statement. When you do a select statement with a where filter, for example, if your partitioning is done properly, you can actually search within a certain area and you kind of prune away some of the partitions at that level, so you effectively look for some of the data. So a lot of the cost when we're working in big data is actually efficiently searching and scanning the data. So this is where traditionally, when you think of like computer science and software development, the algorithm and the complexity and all those different things, that's where this kind of plays into it, where you want to try and think of, okay, if I'm going to run this type of query or this type of operation on the data, how many times am I going to scan over the data? Will I be able to look at some of the partitions effectively? Have I partitioned the data properly? these are all some of the partitioning strategy questions that you need to start thinking about if you're working with big data. Okay. Another one here that I've put is structured workflow. So the way I think of it is more, okay, you need to run specific SQL queries or jobs or different Spark things that you need to run in a process. Can you effectively manage that process and start thinking about, okay, can I run things in parallel? Which things can I run one after another? Which things have dependencies on different things? This is much more of like an abstract skill, but it's less about writing SQL or using big data and more just thinking about it in a graph type format. So we usually call them like DAGs or direct acyclical graphs, where they're kind of like they just go in one direction. But yeah, it's more of a very big data specific skill, and I think it's really useful to think about it, especially for the workflows and how you operate with your data. I think it's really useful and definitely very helpful. And here I've put the last one for an intermediate level of big data practitioner would be, you should be able to know the difference between what is big data and what is maybe not small data, but what is not big data, which is kind of like small data as well. I think when you think of big data and small data, a lot of the times people just say, oh, they're the same thing. One's just larger than the other. That's true, but then we come back to that partitioning strategy and how you're storing things and how you search over different things, and that's more where we want to be in that space when you know the differences and the different implications of using different technology as well. So it's very interesting. I think it's pretty cool. It's one of my passions as well, is to run things very efficiently, and being able to do that with big data is super cool. Okay. Now, if we talk about the advanced skills for big data, like definitely some of those intermediate skills could definitely move into the advanced skills as well. I think when I talk about some of those things in the intermediate, it's more just it's having that knowledge of being able to do some of those things, but not being an expert, and being able to find the experts who actually know those things really well. That's more of the intermediate skill set. When we think of the advanced, you almost think of like your typical data engineer. So someone who's very, very good with all of this stuff. They usually write it instead of PySpark or Spark SQL. They'll be writing it in Spark Scala with very rigorous software engineering skills. So yeah, that's more on the advanced side. And the reason why I've put it in as an advanced big data skill for data science is because a lot of the roles out there are actually expecting some data scientists to have those skills. And sometimes it's very unreasonable. Like I think it's hard enough to learn R and Python and be very good at machine learning, but to also learn Scala and to be very good at big data at the same time. And they're asking for like 5 to 10 years of experience in both of them. It's a pretty big ask. Not many people have that much experience. Okay, so we talked about optimization also. I'll skip talking so much about that, but it's, in a nutshell, it's more about optimization over code as well as infrastructure. So a lot of the times when, say I've worked on Spark projects, for example, it's not about, well, optimizing the code is one thing, but optimizing some of the Spark settings on the cluster actually made much more of a difference. So it's a little bit about knowing some of the infrastructure, but as data scientists, we usually don't need to know so much. It's just kind of finding out some of those things which are helpful from the people who do know. Here I've put type validation, which is more important in the, it's important in all data areas, but being able to know what data types you have, being able to validate schemas and knowing the data quality of different things is super important. And as you get more and more advanced in big data, you realize that that's super important, because if that's not right, everything that you do downstream is probably not right also. And here, orchestration is more around automating all these big data jobs. It's more around working in the cloud, but also can be thought of as running on premise as well if you have Hadoop clusters. But it's, yeah, just making sure that everything is well orchestrated and everything runs seamlessly. If there are failures in certain jobs, what are you going to do about it? What sort of stops or failures or checks do you have? Do you know where the job is running? What stage is it at? All these different things that we can think of as orchestration. And the last piece, governance, it's more of the same around the SQL governance as well. So I'm not going to talk about too much of that. I need some more water. I'm really getting through a lot of words here. Okay. All right. So the next skill will be maths and stats. Oh, I'm starting to get tired actually. So I will try my best to get through all of this. Okay, maths and stats for beginner. So before I dive into this one, what I want to say is that maths and stats is it is important for the data science, but it's not. It's if you don't have a strong maths and stats background, don't worry too much. The level of knowledge that you need to get to actually start using the machine learning is actually not a lot. But what I'd recommend if you're looking to get into a say a junior data science role, the more you can demonstrate that you have some of these math skills, the more effective you will be on the job, is what some of the hiring managers think. So definitely investing some time into this if you want to move into a machine learning and data science space is highly worthwhile. But I know for a lot of people, there's just no time to learn all of that stuff, especially if you don't have a math and stats background as well. So yeah, for everyone who's kind of struggling to kind of pick up with some of the maths and stuff, don't worry too much. You'll actually, like, the way I tell some of my friends now who are trying to get into this area is just start applying the techniques and the methods. And when you need to know about the maths and the stats, that's when you should look into it, where it's a blocker for something where you don't know something about the machine learning or about some of the metrics or different things. That's when you can dive right into the math, and it's a very specific type of learning, which might be better than just learning a whirlwind of all these different math and stats things to kind of like cover off the basic things that people say that beginners need. So just, yeah, something that I'm quite passionate about, because I think too many people say, oh, if you don't have maths and stats, you can't call yourself a data scientist or something. So, which I think is rubbish. So yeah, okay, moving back to here. So as a beginner, here are some of the things that you should have knowledge about, but you don't necessarily need to be expert in. So everything on the left here, I reckon you could probably learn all of these from something like a Khan Academy, or just reading different articles on the web about statistical tests, and you should know enough to kind of cover yourself until you need to know more about it when you run an experiment, for example. So the main thing for statistical tests would be probably your A/B tests, whether something is significant or not, all those p-values. I'm sure there's a ton of articles that you can look into which covers that, so don't worry too much. Some of the other statistical tests would be more of the traditional ones, like testing for normality, maybe also that kind of ties into some of the probability and the discrete probability problems as well. So probability distributions, you might think of, oh, what's a normal distribution, exponential distribution, and some of those things where sure, there's some maths in there, but it's more just about the concept of normal distribution is like the bell curve, for example. Yeah, some of the other distributions, when you look at real data, they don't always look like a bell curve. Some people will say, oh, there's the central limit theorem where if you have enough samples, then everything turns into a normal distribution. But there's also, when you look at the data and you just plot it across all the different values, you get a feel for not just the mathematical distribution, but like the real life distribution of what's going on with the data. I think that's more important than having a lot of in-depth knowledge about probability distributions. Okay. Here I've put discrete probability also. So discrete probability, think of it as The class of problems where, say, you're playing cards and someone asks you, oh, tell me what's the probability for having a king. So there are 4 kings in a pack of 52 cards. So your probability is 4 out of 52. This is the type of discrete probability that we do quite a lot in data science. And honestly, if you can think through some of the problems in that sense, that's probably all you need to start off with. So there's more complex probability. So when you think of Bayes' theorem and some of the other things like that, which requires a bit more thinking and intuition to kind of develop your skills there. I think if you're interested in that area, you should definitely read up on it more. But if currently you're looking at this and you're getting overwhelmed by all the different maths, don't worry too much. Just kind of read like a very simple probability article or something just to get your head around what's kind of needed and what are some of the basic concepts. That might be enough to get you through as a beginner level because you're not expected to know everything as a beginner. Okay. And here I've put like basic matrix math and calculus. These ones, I think they're more important if you're doing machine learning. So say you're doing, you want to actually read some of the mathematics behind the research papers and the machine learning algorithms. You definitely need to know those 2 things. But if you are not too interested in that straight away, then there's no real need to learn it, if that makes sense. So sure, you can jump on Khan Academy and just try out a few different courses and see how you go. But I'm more leaning towards if you want to be a machine learning practitioner or a data science and you want to solve problems, maybe you don't need to know this straight away. And maybe you should only look at it if you are challenged in some way to want to learn more about the internals of some algorithm. So yeah, that's my view on it. Now, if we think of intermediate, so I think for maths and stats, people should be able to understand papers, design experiments, create metrics. So think of business metrics and KPIs and different things like that. I think people who are really good with the maths and stats will be able to create some of those metrics in a very plausible sort of way. But it's more around domain knowledge than it is about maths and stats also. Okay. Where was I? Oh yeah, and the last one is just, I think people with intermediate level of maths and stats, you should be able to implement some simple algorithms from scratch. So simple being, say, a logistic regression, for example, a simple machine learning algorithm. Maybe you should be able to implement a clustering algorithm from scratch. A lot of them, there's a lot of tutorials online to do that. But yeah, that's about as complex as it really gets. Like, on some of the FANG interviews and whatever, they're like, oh, we need you to implement a bubble sort or something different, things like that, like actual algorithms instead of the machine learning algorithms. Honestly, we hardly use those sorts of things in data science. I don't think you're expected to know how to implement them, but definitely for software engineers or machine learning engineers, you might need to know some of them because I think they're more like strictly computer science basics and fundamentals. But yeah, for data science, it's not as important. Okay. And for advanced, I'm just going to read through these because I'm kind of getting a bit tired and my voice is kind of dying out of me. So yeah, for advanced data scientists, you want to create new algorithms. Maybe you have more of an expertise in Bayesian machine learning, so that's very math and stat heavy. This one, if you're more advanced, you should be able to identify statistical errors and fallacies. I could talk about that alone for probably 2 hours by itself, so I'm not going to try and touch that. But over time, as you gain more and more experience, you'll be able to kind of see the holes in some of the stories that people are trying to tell with their data, or they're trying to represent some sort of insight, but then they're missing some key points. And one of the key assumptions that they make might be wrong. So this is more around having that intuition about the data and the mathematical components and principles that underlie that sort of stuff. So it's more around an intuition and just understanding, which comes with experience as well. And the last one is just, if you're really good at maths and stats as a data scientist, you should be able to implement really complex papers. So say like one of the new deep learning papers, you should be close to implement them from scratch, for example, or using some of the packages that implement some of the deep learning techniques. Okay. Software development. I'm just going to read through these and we'll cover it in much more depth because I think software development is a really important area, which is usually data scientists are quite weak in. I think personally for me, I was very weak in the software development, and over time I had to pick up all of this stuff like almost on the fly. And these days, when I look back on where I was when I started with my software skills, I think, well, I learned so much, but it's really not that difficult. You just have to spend more time and focused effort on improving some of those skills and learn from really great people. So yeah, let's just go from beginner. So I've just put basic version control. Usually you're expected to have very hacky code, like maybe notebooks or just random scripts and functions that you just run locally. And usually they might have very simple functions, or it might be super duper complex, much more complex than it really needs to be. So these are what we're expecting from some of the beginners of data science within the software development area. By basic version control, I mean, you should be able to create a GitHub repository, make a few commits, push to master, maybe, make a few more changes, push again to master, but you're literally just working within the master branch and you're using it more like a code storing device as opposed to anything for software development. Okay, when we think of intermediate software development, you'd have proper branch management. So you'd have maybe feature branches, bug fix branches, all these different things which are more around the software development core skill set. You'd have very clean code, so you wouldn't have hacky scripts and Jupyter notebooks and different things like that. You might still be working in Jupyter notebooks for sure, but your code within there should be much cleaner. You should be following some sort of style guide. Your code should be very readable. It should be well structured as well. So if anyone was to come on to your project and start using your code, they should be able to reproduce some of the outputs that you've done for the data science. You may also have done some basic profiling for your work, so for your code, and you know where some of the different things are running really slowly, where some things are running pretty quick. But yeah, you should be able to at least profile it and know what's going on. And you might also have some exposure to cloud computing and some Docker, some container technology. We'll talk about that later in another session. Okay. And the final thing when we think of advanced for software development, pretty much have in mind like a legit software developer. So you want like integrated pipelines with the CI/CD, which is continuous integration and continuous development, where every time you have a new set of changes that you want in the code, you'll have a new release, everything will get built, things will get deployed. Maybe it's all on the cloud. You'll have lots of packages instead of scripts and different things like that. So it actually builds an artifact and deploys it somewhere. You might have bug tracking. So maybe it gets linked, your software and your repo gets linked to a Jira, for example, and you can log all the different things that you're fixing and the different issues. And the last one would just be really, really strong documentation. So in a lot of the Python and the R and Scala, for example, and pretty much any language, computing language, you can write packages and you can also write the code in a way which actually documents how to use some of these functions and classes within your packages. And yeah, that's pretty much your advanced skill sets for software development for the data science. Okay. That was a really long session. My voice, I don't think I've actually sustained talking for this long ever in my life. Like I know I really like to talk a lot, but this is like seriously gone on for a really long time. Yeah, I think, let me do this one quickly. I think this will be the only Q&A that I'll do actually. Okay, so let me describe the Slack channel that I've set up for you guys that are watching and for anyone who's interested in the Data with Danny community. So essentially, what I've wanted to do is I've always wanted to create some sort of community where everyone is all like-minded and we're trying to help each other and improve each other's skills and just kind of have a good time. Like knowing that other people are involved trying to do the same things that we are is super important. And I think it's very cool to just know that others are on the same journey. And having that community where we can you can ask me questions, you can ask other people questions, you can share some of your work, you can if you've shared anything on LinkedIn, you can share your posts on there, and we can try and support you through that as well. I've actually created lots of separate channels within the Slack thing as well, the platform, where they're kind of specific to different topics. So I've got a Python channel, an R channel, Excel channel, all these different things. In hindsight, I should have added everyone as it should have been a compulsory add to everyone who joins the Slack to go into those channels. But I wanted to kind of let people slowly opt into the things which are very important to them. So yeah, I think for anyone who is already on the Slack, please take a look at some of those channels and join them. I think we would have much more active conversation if there were more people in some of those channels, which is my bad. But yeah, for anyone who hasn't joined the Slack channel yet and are interested in doing so, I will share the link probably below in this description. I haven't got it on me right now, but I'll do it straight after this session. Or just head on over to my LinkedIn and just take a look at that. I have a link directly in my profile. Or you can I'm trying out with a different sign up form as well. You can go to datawithdanny.com and just see if that form works as well. You should be able to enter your first name and your email, and then I'll get that and I'll be able to send you a Slack link straight after as well. I'm still trying to work out some of the automations with the email and whatever, so I'm really sorry if you don't see that email too soon. But yeah, I'll definitely get back to you if you sign up through those channels. But yeah, I hope everyone had a ton of fun today. That was a really long session. I will definitely share the slides. There's a few people who are asking for the slides, which is really awesome. Yeah, I'll definitely share the slides. I'll share the clean version in a PDF. Probably, I might do it on the Slack. So anyone who wants it, please join the Slack channel. Otherwise, yeah, I think I'll probably only do it on the Slack just so we can try and build that community spirit and everything. But yeah, I think thank you very, very much. And thank you for supporting me, encouraging me to go through all of the content that I've created. I really need to figure out how to shorten some of the stuff, because all of this that I wrote, I didn't think it would take this long, but I'm glad that I pushed through and I ended up doing everything. So thank you so much, everyone who's been watching and has stayed tuned in to this. I'm sorry I went for so long, but yeah, thank you so much, and I hope you guys enjoy the rest of your Sunday wherever you are, and I will see you soon, probably next week. I think there's a ton of different things that I'm working on also, so I'll share them on LinkedIn. So yeah, watch this space. I think I'll go live again next week, probably, and I'll be active on the Slack channel and on LinkedIn. So please, if you have any feedback or suggestions or comments, hit them up on the comments for this video or on the Slack or anywhere, and I'll try and respond to you as soon as possible. Thank you so much, and I'm going to sleep. See you guys. Take care.